So we're looking at the rest of circles today, tangents, normals, and circle theorems. Tangents and normals kind of link in with when we're doing parallel lines and perpendicular lines, and then we'll look at some circle theorem stuff. So first of all, so the tangent to the circle is the line that touches the circle in one place and is at right angles with the line extending from the radius. So tangent perpendicular to our circle. And if you look here, the circle and the tangent kind of have the same gradient at that point. As you can see there, the curvature of the circle and the line of tangent, same gradient. And the normal then is the line going through the centre of the circle, which is going to be perpendicular, if you like, to the circle, but have the same gradient as the radius. So just to summarise, tangent perpendicular to the radius and passes through one point, and the normal same gradient as the radius and passes through the centre. So let's try some examples. So calculate the equation of tangent to the circle at that point. So it's easy to get mixed up with tangent and normal. Remember, the tangent is going to be perpendicular to the radius, if you like. So we're going to work out the gradient of the radius, negative reciprocal of that, and that's going to let us find our tangent. So I'll do a quick sketch as well. There's our point, there's the centre. We're going to find out the equation of this line and do the negative reciprocal with that point to find the equation of that line. So our gradient of radius, well, we know the centre of the circle, we can work out this point here. So there's our 2 points. So that's the gradient of the radius. So the gradient of our tangent is going to be the negative reciprocal of that. So for above. And then we know our gradient, we know the point we need to pass through. So y plus 7 equals 3/4 x minus 8. Expand that. Minus 6. Yeah, times everything through by 4. And we have 4. So we get 4y minus 3x plus 52 equals 0. And that's the equation of our tangent. Alright, now let's try and find a normal to a circle. So, equation of the circle's there, there's the point, we want the normal this time, so find the radius, same gradient passing through that point. So if you guys want to pause it and try it, you can. I'll go through it now though. So our gradient, the gradient is going to be 2. So be careful, plus signs there, minus, minus, but minus, minus is plus, minus, minus is plus. Then we get y minus 5 equals 2x plus 1. So y equals 2x plus 7. Cool, that's really it. Just be careful, remember which is which. Normal, same gradient as the radius, tangent, perpendicular. Negative reciprocal gradient. Right, onto some circle theorem bits. Okay, so the first circle theorem we're going to look at is something called the circumcircle. And circumcircle is basically a triangle that you draw through a circle. And there's some specific properties about this. So it's always possible to draw a circle with vertices, 3 vertices of a triangle. Not done a great job, but you could fit an exact circle equation with a constant radius to any triangle. So the circle, we call it the circumcircle of the triangle, and we're going to be able to work out how to find some of these equations. So we've got something called the circumcenter, which is basically the centre of the circumcircle, and you can find that by finding the perpendicular bisectors of each of the sides of the triangle, and where they intersect is where the centre of the circumcircle is. So if you imagine this line, if we perpendicularly bisect it, get a line there. AF will perpendicularly bisect this line, we get one there, and this one, maybe there. So in my awfully drawn circumcircle, the centre would be where those three perpendicular bisectors intersect each other. So we can find the midpoints of each of these sides, find the gradients, find the perpendicular bisectors, find perpendicular gradients to find the perpendicular bisectors, and where they intersect is the centre. So that'll give us the coordinates of the centre. We can then find the length of the radius and get the equation of a circle from the 3 points of the triangle. So loads of steps there. We're going to try an example of this. It's quite involved, but it really tests your knowledge of coordinate geometry so far. So pause the video, copy this one down and give it a go and see if you can find the equation of this circle or this circumcircle. Right, so I'll start going through this now. So a quick sketch. So that's what we're doing. We've got 3 points roughly, we've got a circle there. We're going to try and find the perpendicular bisectors and find where they all meet. Okay, so I'll find AB first, then BC, and then CA, and I'll put them all together at the end. So the gradient of AB, using 2 points of the gradient equation, is a third. So the perpendicular gradient is going to be -3. Now we need the midpoint. So I remember midpoint, average of x's, average of y's. 7 minus 2 over 2, minus 5 minus 2 over 2, which gives us 5 over 2 minus 7 over 2 as our midpoint. So if we combine those two aspects, we can find the equation of the perpendicular bisector to AB. So there we go, and kind of following that one through, we end up with times it all by 2. And we end up with y equals minus 3x plus 4. So that's our perpendicular bisector for AB. Right, so very quickly if we go through the other ones, we end up with BC, midpoint of 7 over 2 minus 11 over 2. Put that into the line equation. So we get y equals minus x minus 2. And last one, CA. So perpendicular gradient is a half. Midpoint, average of x, average of y, we get minus 1, minus 7. So put that into the line equation again. And that leads us to y equals x over 2 minus 13. So we've got 3 perpendicular bisectors. Where those lines intersect is going to be our centre. So we just need to find the intersection of those lines. So we'll solve them simultaneously. Right, so let's just go for these two because they don't have any fractions in. So set the y's equal to each other. And now rearrange and solve. We get x is 3. Now let's put that back into this one. So we get 3 and minus 5. Now I didn't actually use this equation, so let's now try and see if this equation and this equation also solve to give 3 minus 5. So it's really fast. Yeah, x does equal 3, and then we put that in for minus 5. Good. So that is our midpoint for this circle. Now we just need to find the radius. Right, so to find the radius, it's going to be length between that point and one of these points. Doesn't really matter which one you use. I think I'm going to use this one, so between those two. So remember the length is going to be y2 take y1 squared. So if we go for minus 5 plus 5 squared plus x2 take x1 squared, so 3 minus minus 2, 3 plus 2 squared, which ends up being 5 squared, 25, root that, so that equals 5. So our radius is 5, so we can put all this together now into the equation for a circle. 1 minus 3 squared plus x plus 5 squared equals the radius squared, 25. So that is the equation of the circle passing through the vertices of that triangle. So that's our circumcircle. Excellent. Right, a couple other theorems, and then we're done for today. These are quite nice, quick ones. Okay, so first circle theorem, the angle in a semicircle. So if that's our diameter, the two chords joining it making a triangle, that angle is always a right angle, it's always 90 degrees. So this is quite useful for right angle triangle. So it means that the hypotenuse of the right angle triangle, so this length here, is the diameter of its circumcircle. So I'll try and draw that. Not too bad. So that would be our diameter, because it's the hypotenuse, because the side opposite it is the angle opposite it is the right angle. And that works for any triangle. If I drew one up here, still a right angle, drew one here, still a right angle, drew one all the way over here, still a right angle. So that's the first circle theorem. Oh, that's actually the only one we're going to have. Cool, right, last question then, really quick. So 3 points lie on the circle, prove that AB is the diameter. Well, if all 3 points lie on the circle, ABC, if AB is the diameter, it must mean, as we just saw, that AB is, that the triangles are right angle triangles. If I put B there and C there, it must be a right angle triangle if AB is the diameter. So if we can prove it's right angled, i.e. if we can prove Pythagoras works with it, then we're done. So we're going to find the length of AB is BC and CA. And if Pythagoras holds up with these three lengths, we know it's a right angle triangle, thus we proved that AB is the diameter. So let's work out all these lengths. So we get AB is root 160, BC is root 80, CA is root 80. So in this triangle we know that AB is definitely the hypotenuse, as we expected. And do those all work in Pythagoras? Well, yes, that squared does equal that squared plus that squared. So we can say therefore Pythagoras works, therefore right angle triangle, therefore AB must be diameter due to circle theorem. Cool, alright, that's it for today. So if you guys can get onto the quiz and do some practice on circles and circle theorems. Excellent. I think next time we're moving on to a new topic, which is binomial expansion.